Aim of this experiment is to study the effect of acetylcholine on dog's heart. Objectives of this experiment are to record and understand mechanical activity of heart, to understand chronotropic and inotropic effects, to understand mechanism of action of acetylcholine on heart, to understand the terms bradycardia and tachycardia. Parasympathetic system consists of preganglionic nerve fiber, autonomic ganglion, and postganglionic nerve fiber. Within ganglion, preganglionic nerve fiber synapses with postganglionic nerve fiber, which are innervated by nicotinic receptors. Acetylcholine is neurotransmitter of autonomic ganglion. Postganglionic nerve ending releases acetylcholine, which will interact with effector cell, example heart cell, innervated by muscarinic receptor. SA node is pacemaker of human heart, which regulates heart rate. Acetylcholine reduces rate of depolarization of SA node and thereby reduces heart rate. You can see the gap between two action potential peaks is more in presence of acetylcholine. Acetylcholine reduces force of contraction of cardiac muscle along with heart rate. By increasing permeability to potassium ions, acetylcholine hyperpolarizes cardiac muscle, which leads to decrease in contractility. We have already learned the isolation technique of frog's heart preparation. For studying effect of acetylcholine on frog's heart, perfuse the heart with frog ringer solution. Now start the drum and record normal contractions of heart on smoked paper for 1 minute. From the pattern recorded on the drum, you can see contractions of cardiac muscle and relaxation of the same. This event of contraction and relaxation is observed in the form of a single peak. Upgoing part of peak represents muscle contraction and reverse indicates relaxation. In these tracings, the number of peaks per minute indicates rate of contraction of heart, whereas height of a single peak indicates force of contraction. You can see that all the peaks in the tracing are of the same height and at the same distance. This means contractions are rhythmic and with normal tone. Now stop the drum, inject 0.1 ml of acetylcholine solution into the cannula. Start the drum immediately and record the response of heart on the smoked paper for 1 minute again. You can see that the rate of contraction and force of contraction of heart reduces due to acetylcholine. Also observe the rhythmicity and tone of contraction. Repeat the same procedure by injecting 0.2, 0.3 and 0.4 ml of acetylcholine. Allow a time gap of 5 minutes between two successive doses to wear off the effect of earlier dose. From these observations, we can say that acetylcholine has negative chronotropic and negative inotropic effect on heart. Thus, cholinergics find application in tachycardia. You have learned that acetylcholine inhibits heart functioning by increasing its rate and force of contraction. Acetylcholine mimics muscarinic action.